Okay, so we're starting on a new section, 5.1, which deals with rules of exponents. So it's so vital that if you want to be successful in algebra, especially when you get into college algebra, you need to remember basically these rules for um, exponents and as well as radicals. But right now we're just focusing on the exponents. So when you have two here, right? So exponential functions. A to the m times a to the n, you just add the powers. If you have a to the m raised to the n, so a power raised to a power, then you multiply those power. So it'll be amn. If you have a times b to the n, and this is a common mistake students make, this only applies when the two terms are being multiplied. Okay? So if there is an addition in the middle or minus in the middle, you cannot apply this rule. It only works when the two terms are being multiplied. Okay? So this will be a to the n times b to the n. If it was a plus b to the n, this will not, the rule will not apply. It wouldn't be an plus b to the n. Okay? That is a common mistake that many students make. Okay? This one is being divided, so a over b to the n will be a to the n divided b to the n, and then a to the m over a to the n. So if you want to move a term to the top, you just make the power negative, or in this case, you just subtract them. All right, so when you multiply, you add the exponents. When you divide, you subtract the exponents in layman terms. Okay. And then this one, if it is a negative power, so basically to make it positive, you just move it down to the denominator and vice versa. Okay? So these are the rules that will make and break students. Okay? So let's do some examples. All right. So let's look at these examples. Right? So say for number one, we have 5 to the third times 5 to the third. So I'm just gonna label this, say rule one, two, three, four, five, and six. Okay, so we're gonna apply rule number one here. Okay, I'm gonna say rule number one here. All right, for this one. So again, we have the same base, right? I'm talking about these here. These are the bases. Okay, and then these are your exponents. Okay. So since the bases are the same, then we can just, applying rule number one, we can just add them. Okay, so this would be 5 raised to the 3 plus 3, which gives us 5 to the 6. Okay, which we put in the calculator becomes 15625. So that will be the answer for this one. Okay, the second one is the same thing, right? We're going to use rule number one because the bases are the same. All right. Sorry, I put two there. One. Using rule number one. This is the rule I'm applying. Okay. I'm using rule number one, and the bases are the same. So then I get to add the exponents. So that would be a to the 5 plus 2 gives us a to the 7th power. And then there's nothing else I can do, so that's our final answer. Okay, so why don't you guys try the next one there and tell me what you get. Yes, so the third one here is going to be y to the 10th power, right? Because we're just adding the powers, correct? So it'll just be y to the 7 plus 3 plus 0, okay? Which gives us y to the 10th power, okay? All right. Then the next one, what about that one? So that one, again, we used rule number 1 for that one, okay? Right? How about the next one? What did we get for that one? All right, so and this one, the next one here, we would multiply the coefficients, so negative 2 times 5, okay? Just going to break this down here. And then we're going to multiply the y to the 6 times y squared, okay? So that's going to give us negative 2 times 5 is negative 10. And then we just said no, y to the 6 times y to the second. And we're just going to add the powers there. Okay? So that's going to give us y to the 8th power. Okay? So our answer here is negative 10 times y to the 8th power. Okay? All right, so how about the next one there? So again, we're going to match these guys. Okay? And then we're going to match these guys here. So that's going to give us a square times negative a times b to the third times b squared. So this will give us, this will be to the 1 power, right? So that's going to give us a negative a here. And then 2 plus 1 is going to give us 3. And then this will be 3 plus 2, which gives us 5. So that'll be negative a to the third power times that by b to the fifth. Okay, so that would be our answer there. And again, we're still using rule number 1 for all of these. All right, so what are we going to have for the first one? We got negative 5, negative 0.5 raised to the 0 power. What is that going to be? What do you think? It's not 0, 1, right? It's going to give us 1. Okay, so if we had, say, 3 to the 0 power, what does that give us? What would 3 to the 0 power be? No, 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 1. Okay, 3 to the 0 power is 1. What about 2 to the 0 power? What's that going to give us? 1. Yes. Okay. So negative 0.5 to the 0 power is going to give us 1. Okay. How about this one? We got negative 9 times 45 to the 0 power. What's 45 times to the 0 power? What's 45 raised to the 0 power? 1. Yes. Right. So this is going to be 1. So it'll be negative 9 times 1, which is negative 9. Okay. How about this one here? We got x squared, okay, times y to the third to the 0 power. What do you think that's going to be? 1. Okay. This is going to be 1 as well. All right. The only time it's not 1 if it's infinity to the 0 power or 0 to the 0 power. These ones we don't know. But everything else, is to 1. So the question is, why is it 1? Well, let's think about this. Well, first of all, does anybody know why it's 1? Okay. All right, so let's say we have 2 squared divided by, let's say 2 to the third divided by 2 to the third. Okay? All right. So, um, what do we know about 2 to the third? Well, that's just 2 times 2 times 2, right? Okay. Which is what? 2 times 2 is 4. 4 times 2 is 8. So there's 2 times 2 times 2. So this will give you 8 on top, and then we'll get 8 on the bottom, right? So 8 divided by 8 is going to give us 1. Okay? You're like, well, how does that apply to 0? Well, let's talk about what we just learned about division, right? So if we're dividing, then we subtract the powers. So in this case, we have 2 to the third minus 3. Well, what's 3 minus 3? Is 0. So 2 to the 0 power. Okay? So every single one of these follows this same um, evaluation. Okay? Exactly the same. Doesn't matter what number you give me, I'm going to get the exact same type of work. Okay? Which produces to the 0 power. Well, what did we just say this was? Well, that's equal to 1, right? So any number besides 0 and infinity raised to the 0 power will give you 1. Just to do a really real quick recap here. So 2 to the 0 will give us 1. 3 to the 0 is equal to 1. Negative 0.5 to the 0 is 1. Negative 9 times 45 to the 0. Well, negative 9 is still negative 9. 45 to the 0 is 1. So negative 9 times 1 will give us negative 9. And then this here, x squared times y to the third raised to the 0 power will give us 1. And the question is, why is this the case? And give me any number or variable raised to the 0 power will give us 1, except when it's infinity or negative infinity to the 0 power or 0 to the 0 power. Those we don't know. Okay? So here I showed why that is the case. If you have 2 to the third divided by 2 to the third, if you expand 2 to the third, it's 2 times 2 times 2. Okay? Which gives you 8. And the denominator, same thing. Well, 8 divided by 8 is 1. Well, we just learned that if we are dividing two exponential terms, okay, we will use rule number 5, where we would subtract the powers. Okay? So when we subtract the powers, right, that will become 0. Well, 2 to the 0, we just indicated that equals to 1. Okay? So that's why every one of these will follow this type of process. And when it comes to any number besides infinity or 0 raised to the 0 power. All right, so for these ones, we need to use, again, the exponents rule to figure these out. So the first one we have is 10 to the third raised to the fourth power. Okay, so as I mentioned, a power to a power, you multiply. Okay, so this will be rule number 2. Okay, so we would use rule number 2 here. Okay, and we just multiply. So that would be 10 to the third times 4, which gives us 10 to the 12th power. Okay, so same for this one, right? We have a power raised to a power. So we just multiply it. So that's going to give us z raised to the 3 times 2, and then you have 5 times z to the 5th. So I need to figure this one out first. So z to the 3 times 2 is z to the 6 times 5 times z to the 5th. So that gives us 5 times z to the 6 plus 5, which is 5 times z to the 11th power. Okay, I'm going to skip 3 right now, go to 4. This one here is being divided, but the principle is the same. I have to square the top and then square the bottom. Okay, and again, that only works when we're multiplying and dividing. That doesn't work if we were adding or subtracting in that parentheses. So this would be 5 square over 2 square, which gives us 25 over 4. Okay, questions so far? Okay, so why don't you guys try 3, 5, and 6? Try 3, 5, and 6. Okay, so this one, I'm going to use rule number um, 3, right? I can use rule number 3 here. Rule number 3, this one right here. Okay, can use that one. So this is going to be -4 raised to the third times that z to the third power. Okay. All right, so -4 to the third power, that's going to give us -64, and then z to the third is still going to be z to the third. So our answer is going to be -64 z to the third. Okay. Now for number 5 here, right? These are being divided. Again, I can distribute when being multiplied. So these are being multiplied, okay? Or they're being divided, okay? So that means I can just distribute those two. So that gives us x squared divided by 2 squared, which gives us x squared over 4. All right, and then the last one there is the same thing, okay? So this would be a minus b raised to the third divided by 2 to the third. So that'd be a minus b to the third over 8. All right, so the first one, what do we have here? So what we want to do is we want to distribute that power too, right? So this, again, that only works because these are being multiplied. If it's addition or subtraction in the middle, we can't do this, okay? So, but it's being multiplied, so I can distribute that 2 here. So, so this one here becomes x to the 4th times y to the uh, 8, right? Let me backtrack a little bit here. So we have x to the 3rd times y, right? From here. Then we're going to distribute that square. So that'll be x squared raised to the power of 2, and then y fourth raised to the power of 2. Okay, so so here we'll have x to the fourth times y to the eighth, because remember, a power to a power, you multiply. 2 times 2 is 4, 4 times 2 is 8. Then we combine the ones that are like terms. So x to the third times that by x to the fourth, and then we have y to the first times that by y to the eighth. Okay? So that's going to give us x to the seventh times y to the ninth power. We just add the powers because the bases are the same. So 3 plus 4 is 7, 1 plus 8 is 9. Okay? So our answer here is x to the seventh times y to the ninth power, which many of you guys got. Okay? Second one, same thing. We're going to distribute that 5 to each term because they're being multiplied. Okay, so a squared to the fifth times b third to the fifth. The denominator will be 3 to the fifth. Okay, so then a power to a power multiply. So 2 times 5 is 10. 3 times 5 is 15. And then 3 to the fifth power is 243. Okay. So that's our answer for the second. All right, the third one, we have x to the x minus y to the fifth and x minus y to the fourth. Notice that the bases are the same, okay? Or the factor, they're the same. So we can apply rule number 1, where the bases are the same, we can just add the powers. So in this case, we'll have x minus y raised to the 5 plus 4, which gives us x minus y raised to the ninth power. And there's our answer. Okay. All right, this one, if we break this down, okay, we have x to the 0 times y to the 0, and then z 2 times 0, right? So that'll also give us 0. So we know that anything raised to the 0 power besides infinity and negative infinity and 0 will just be 1. So it'll be 1 times 1 over 1, which gives us 1. Okay? All right, and then the last one, we're going to distribute this. We have r plus t times rt. We're going to distribute that to each of this term. So we have r times rt plus t times rt. Okay? So that's going to give us r squared t plus, this will be rt squared. And we don't want to combine anything because there's an addition there. If they were both the same, then we can add them. But since they're not the same, we have to leave them the way it is. So that's our final answer here. All right, so we have x minus y times x squared times y cubed. Okay? So if you understand how to do this, you're ahead of the game. All right? This is where a lot of students mess up. Okay? So again, I'm going to take all of this here. There's a different color here. I'm going to take all of that here. Okay, take all of this here and then multiply that to each term. So I'll have x squared, sorry, x times x squared y to the third minus y times x squared y to the third. Okay? And then I just simplify. So x times x squared. So this is not saying like x times x squared and then x y to the third. I'll see that on the test. That's a no-no. Okay? We don't do that. All right? So please don't do that, but I'll see that on the test. Okay? So these are all being multiplied. This is like saying 2 times 3 times 4. It's not like 2 times 3 plus then times 2 times 4. That's not the case. Okay. So anyway, so we have x to the third, right? Because this is a power of 1. So x times x1 to the times x squared will be 1 plus 2, which just gives us 3. So x to the third and y to the third. And then this one will be y x to the second. But if I backtrack here, I have y to the 1 and y to the third. So if we just add the powers there, so 1 plus 3 will give us 4. Okay? Now don't try to combine this. This is not true. Okay? Don't try to say, oh, this is x and this is minus y or something. That's not true. Again, I'll see that on the test, but that's not true. Okay? So that's all we can do here. Okay? There's nothing else we can do. Now again, if they have the same power, same they have the same basis, but they don't have all the same power. If this was a 3 and that was a 3 and this was a 4 and that's a 4, then we could combine them. But that's not the case here. Okay, so let's try our next one. This one here, we want to find the area or the volume. Okay, so we want to find the area or volume. Okay, so let's label this 1, 2, 3. All right, see if we can figure that out. All right, so this is we want to find the area or the volume. So the area of a square or rectangle is just base times height, right? So area is base times height. So the base here is 2AB, and then the height is 2AB. Okay? So we just multiply this. 2 times 2 is 4. A times A will give us A squared, and then B times B will just give us B squared because it's 1 plus 1 is 2. Right? So that will be our answer for this one. The next one here is just a triangle, so the formula for that will be half times base times height. The base here is 7y to the third, and then the height is 4y squared. So 7 times 4 is going to give us 28, so that's going to be 1/2 times 28, and then y to the third times y squared, well, again, it's the same base, so we can just add the power. So 3 plus 2 is 5. So that gives us y to the fifth power. Well, half of 28 is 14. So that would just be 14y to the fifth power. Okay. So that's our answer for the second one. Now for the last one, it's the volume, right? Because length times width times height. So this is length times width times height. So you can apply that for a cube or a rectangular prism. So in this case, all of them are the same length because this is a cube. So there'll be 3a squared times 3a squared times 3a squared. Okay, so 3 times 3 times 3, well, that's going to give us 27. Then a squared times a squared times a squared, well, that's going to be 2 plus 2 plus 2 will give us 6. So that'd be 27a to the sixth power. And that's our answer there. Okay, this is compound interest. It says if P dollars are deposited in an account that pays 9% annual interest, then the amount of money in the account after 4 years is represented by p times 1 plus 0.09 raised to the fourth power. Find the amount when p is $500. All right, so these types of problems, compound interest especially, you have to be careful how you type it in the calculator. You have to apply PEMDAS, so you have to do inside the parentheses first, then raise it to the exponent or the power, and then multiply it by p at the end. Okay, so for example, in this case, give me a second. Okay, so here we have p times 1 plus 0.09 raised to the fourth power, right? And they tell us find the amount when p is 500. So we're just plugging in 500 here. So that'd be 500 times 1 plus 0.09 raised to the fourth power. So which I just mentioned, we need to do inside the parentheses first. Okay, so we have to apply PEMDAS here when entering this in a calculator. So we get inside the parentheses 1.09, then raise it to the fourth power. Okay, so if we get our calculator here, all right, so we get 1.09 and then raise it to the fourth power, we get this much. Okay, and then at the end, we're going to multiply by 500. Okay, so let's do that. Let's multiply by 500. Right, so we get 705.79. So this would be 705.79. This is big money. Okay, so notice here I didn't round anything. All right, so you want to keep whatever you have. Okay, and again, if you round at the beginning, it's going to take you further away from the exact answer. So you want to keep those intermediate computations as much as you can, and then at the end you can round. Okay, so here's your answer.